Good morning, students. So the last class we are discussing about damping oscillation and undamping oscillations, and today I am going to discussing what is that what is current sensitivity, voltage sensitivity, and charge sensitivity. Okay, with their problems. But before I am going to discussing about that one, here we know that already we know that what is that the charge of the ballistic galvanometer, that is the Q equal to what is that CAT upon 2 pi NAB into theta. So this is what is that the charge of the ballistic galvanometer. So this equation can be written as what is that Q equal to T upon 2 pi C upon NAB into theta. So this is what is that Q equal to K into theta, where K is equal to what is that T upon 2 pi C upon NAB. Okay, so the upper equation can also be written as, so this means the Q equal to what is that T upon 2 pi C upon NAB into theta. Okay, here the Q equal to what is that T upon 2 pi K into theta, where K is equal to what is that C upon NAB. Okay, it means the Q is directly proportional to the theta. It means the charge is proportional to the deflection of the BG. Okay, so up to this we are discussing about the moving coil ballistic galvanometer. Okay, at the continue of this one, this relation gives the charge flowing through the galvanometer and the ballistic through the theta of the galvanometer. Okay, so this relation, so the above relation, it means this relation gives the charge flowing through the galvanometer and the ballistic through theta through the what is that galvanometer. Since the torque or couple of the suspension fiber is C into theta, which is the coupling for the twist. Okay, coupling for the twist. Okay, that is N into I into A into B equal to what is that C into theta, where N is the number of turns of the coil and I is the current and A is the area of the coil and B is the magnetic field, and that is equal to C into theta. So this equation can be written as what is that C I equal to what is that C upon NAB, C upon NAB into theta, where that is equal to K into theta, where K equal to what is that C upon NAB. It means that I is directly proportional to theta, that is the current is proportional to the deflection of the BG. Okay, and the above equation what is that Q is directly proportional to the theta, and this one what is that I is directly proportional to the theta. Okay, up to this one write down the moving coil ballistic galvanometer. ಆ ಮೂವಿಂಗ್ ಕಾಯಿಲ್ ballistic galvanometer ದಾಗ ಏನು ನೋಟ್ಸ್ ಬರ್ಸಿದ್ದೀನಲ್ಲ, ಸೊ ಇದನ್ನು ಒಂದು ಸ್ವಲ್ಪ ಬರ್ಕೊಂಡ್ಬಿಡ್ರಿ. ಓಕೆ, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ದಿ that the derivation. Okay, the next one. Okay, the next what is that current sensitivity. Here what is mean by current sensitivity? So current sensitivity of the ballistic galvanometer is defined as the deflection per unit current, that is the deflection means what is that theta. Okay, per unit current, that is the I. Okay, the current sensitivity that is equal to SI. Here the SI is what is that current sensitivity is denoted by SI. The current sensitivity is denoted by SI, that is SI equal to what is that theta by I. Okay, here we know the value of the I. Here this one I equal to what is that C upon NAB into theta. So now we have to substitute I value in this equation. Okay, that is SI equal to what is that theta into NAB divided by C into theta. So here that way theta is there, we have to cancelling on both sides, the upper and lower end. So that will be theta will be cancelling, remaining what is that SI equal to NAB upon C, and this is also be written that is also equal to what is 1 by K, because K is what is that C upon NAB here, but NAB upon C is equal to what is that 1 by K. This is what is that current sensitivity. Okay, the next one, the charge of the charge sensitivity or quantity sensitivity. So here also sometimes it is also called as what is that charge sensitivity, is also sometimes called as what is that quantity sensitivity. Okay, the charge sensitivity is defined as the deflection per unit charge. Okay, the deflection per unit charge, that is theta by Q. Okay, the charge is denoted by that charge sensitivity is denoted by what is that SQ, that is equal to what is that theta by Q. So here we know the charge of the ballistic galvanometer, that is the Q value. We know that is Q. Here what is that, here what is that T, Q equal to T by 2 pi into C upon NAB into theta. So now we have to substitute this value in this above equation. Here we have to substitute the Q value in this equation. What is that SQ equal to theta into NAB into 2 pi divided by C into T into theta. So here theta is there, lower and upper end, we have to cancelling on both sides, remaining what is that SQ equal to 2 pi T into NAB divided by C. Okay, here SQ equal to 2 pi by T into SI, because SI is what is that current sensitivity, that is SI equal to NAB divided by C. Therefore we have to substitute the SI, that is the current sensitivity. So here what is that? The charge sensitivity equal to 2 pi by T into current sensitivity. So this formula is important for the problems. Okay, this is the note down. That is SQ equal to 2 pi by T into SI. So SI equal to we have to return as what is that? Theta by I. Okay, because that is a deflection per current. Okay, that is also SI. Okay, so next one, voltage sensitivity. Here the voltage sensitivity means the deflection per unit voltage. What is that? The voltage sensitivity of the ballistic galvanometer is defined as, that is deflection per unit voltage, that is theta by V. Here SV equal to, it means the voltage sensitivity is denoted by SV. Okay, that is SV equal to what is that? Theta by V. Okay, the next one, figure of merit of ballistic galvanometer. What is mean by next? What is that? Figure of merit. The figure of merit means the figure of merit of a galvanometer is a current which will be produce a deflection, on one division on scale. One division equal to what is that? 1 mm. In the galvanometer, one division equal to 1 mm. Okay, on a scale 1 meter from the mirror. Okay, the figure of merit means the figure of the merit of the galvanometer is current which will be produce a deflection, of one division, that is one division equal to what is that? 1 mm on a scale 1 meter from the mirror. Okay, this is the figure of merit. Okay, so suppose they are asked to you what is that? Define figure of merit, or define voltage sensitivity, or define charge sensitivity, and define what is that? Current and charge sensitivity both. Okay, so these are the 2 markers in important questions. Okay, the next one. Okay, problems. Here what is that? The first problem is what is that? The current sensitivity of the ballistic galvanometer is 4.4 into 10 raised to minus 9 ampere for a deflection of 1 mm on a scale kept at a distance of 1 meter. Okay, calculate the charge sensitivity of the galvanometer if the periodic time of the coil is 3.14 second. Okay, so here they are given SI, that is the current sensitivity of the ballistic galvanometer is what is that? 4.4 into 10 raised to minus 9 ampere. That is current sensitivity SI equal to what is that? 4.4 into 10 raised to minus 9 ampere. Okay, the next one, T equal to what is that? 3.14 second. T equal to 3.14 second. Okay, they are asked to what is that? Charge sensitivity. Calculate the charge sensitivity, that is SQ equal to, we are finding that one. Okay, that is, we know that the formula, what is that? SQ equal to 2 pi by T into SI. It means the charge sensitivity equal to 2 pi by T into current sensitivity, and they are given the T and current sensitivity. We have to substitute the value in this equation. What do we get? SQ equal to 2 into pi is what is that? 3.142, and divided by the time is what is that? 3.14214, and SI equal to what is that? 4.4 into 10 raised to minus 9, and the final answer what is that? Okay, that is 8.805 into 10 raised to minus 9 coulomb per mm. Okay, coulomb per mm. So we have to calculate this one. Okay, ನೀವು calculation ಮಾಡ್ರಿ ಎಷ್ಟು ಆನ್ಸರ್ ಬರ್ತೈತಿಲ್ಲ calculation ಮಾಡ್ರಿ, ಇದನ್ನೇ ಕಾಪಿ ಆ್ಯಂಡ್ ಪೇಸ್ಟ್ ಮಾಡೋಕೆ ಹೋಗ್ಬಿಟ್ಟು calculation ಮಾಡ್ರಿ. Okay, the next one, the second problem, what is that? When 0.1 coulomb of charge is passed through a moving coil BG, that is the ballistic galvanometer, a deflection of 30 mm is observed on a scale 1 meter away. Okay, find the current sensitivity of the galvanometer if the time period of the coil is 10 seconds. Okay, here they are given charge. It is not a charge sensitivity. Okay, they are not given the charge sensitivity, they are given the charge, that is 0.1. Okay, the Q equal to 0.1 coulomb, and theta equal to, the reflection is 30 mm, that is theta equal to 30 mm, and T equal to what is that? The time of the coil, time period of the coil is what is that? 10 seconds. But they are asked to what is that? Current sensitivity. Okay, here we know the formula, what is that? SQ equal to 2 pi divided by T into SI. Okay, but they are asked to what is that? Current sensitivity. Therefore this equation, this formula can be written as what is that? SI equal to T by 2 pi into SQ. Okay, but they are not given the charge sensitivity, they are given what is that, charge and deflection. Therefore we know the charge sensitivity SQ equal to what is that, theta by q. So now we have to, what is that, SQ equal to theta by q substitute ಮಾಡ್ತೀನಿ. and theta ಕೊಟ್ಟಾರ ವ್ಯಾಲ್ಯೂ 30 ಕೊಟ್ಟಾರ, q ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾರ 0.1 ಕೊಟ್ಟಾರ, and t ವ್ಯಾಲ್ಯೂ 10 ಕೊಟ್ಟಾರ, 10 ಸೆಕೆಂಡ್ ಕೊಟ್ಟಾರ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ we are getting the 477 mm per ampere. Okay, mm per ampere. Okay, this is the final answer. You have to calculate this one. Calculation ಮಾಡ್ರಿ, ಅದು ಎಷ್ಟು ಆನ್ಸರ್ ಬರ್ತೈತಲ್ಲ ಅಷ್ಟೇ ಮಾಡಿರಿ, ನೀವು ಅದನ್ನೇ ಇಡಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ಓಕೆ, ಅದೆಷ್ಟು ಬರ್ತೈತೆ ನೋಡಿರಿ, ಅದು ಅಷ್ಟು ಆನ್ಸರ್ ಬಂದಿದ್ದು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿಡ್ರಿ. ದ ನೆಕ್ಸ್ಟ್ ಒನ್. Okay, the third question, the third problem, what is it? A ballistic galvanometer produces an initial through of 50 mm. When a certain charges flow through it, the same galvanometer gives a deflection of 10 mm for a steady current of 0.1 microampere. Its periodic oscillation is 6 seconds. Determine the charge sensitivity and current sensitivity. So here they are asked to you both charge and current sensitivity, but they are given theta, that is the deflection, what is that, 10 mm, and the current I equal to what is that, 0.1 microampere, and t equal to what is that, 6 seconds, and they are asked to what is that, charge and current sensitivity. So here we know that the formula is q equal to 2 pi by t into si. Okay, here SI equal to what is that, theta by I, that is the current sensitivity, what is the deflection per unit current. So theta equal to, first ಏನು ಮಾಡೋಣ, current sensitivity ಕಂಡುಹಿಡಿಯೋಣ, ಆಮೇಲೆ ಏನು ಮಾಡೋಣ, current sensitivity substitute ಮಾಡಿದಾಗ we are getting the charge sensitivity. Okay, so we know what is that, SI equal to what is that, theta by I. Okay, so theta value ಹಾಕೋನು, I value ಹಾಕೋನು, we are getting the what is that, SI, that is 100 microampere per mm. Okay, so SI ಸಿಕ್ತು, ಅದೇ SI ಏನು ಮಾಡೋಣಪ್ಪ ಅಂತಂದ್ರೆ SQ ಫಾರ್ಮುಲಾ ಹಾಕೋನು, SI SQ equal to what is that, 2 pi by t into SI ಹಾಕಿದಾಗ we are getting the ಚಾರ್ಜ್ ಸೆನ್ಸಿಟಿವಿಟಿ. ಓಕೆ, ಈ ಥರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರ್ತಾವೆ. ಸೊ ಚಾರ್ಜ್ ಸೆನ್ಸಿಟಿವಿಟಿ, ಚಾರ್ಜ್ ಕೊಟ್ಟಾಗ ಚಾರ್ಜ್ ಸೆನ್ಸಿಟಿವಿಟಿ ಕೊಟ್ಟಾಗ ಕರೆಂಟ್ ಕೇಳ್ತಾರೆ, ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ ಕೊಟ್ಟಾಗ ಚಾರ್ಜ್ ಕೇಳ್ತಾರೆ. ಸೊ ಎರಡೂ ಒಮ್ಮೊಮ್ಮೆ ಎರಡು ಅಂದರೆ ಚಾರ್ಜ್ ಸೆನ್ಸಿಟಿವ್ನು ಕೇಳ್ಬೋದು ಅಥವಾ ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವ್ನು ಕೇಳ್ಬೋದು, ಈ ಥರ ಕೇಳ್ತಿರ್ತಾರೆ. ಏನಾತಂದು